Good afternoon today to our next webinar. Today we have an active high available cluster based on our flagship product data storage software V7 with fresh VMware product ESXi 5.5. I just want to remind you that we have made finally also the DSS V7 certification with 5.5. The certification is on the hardware compatibility list in VMware available. Okay, what we are going to do today is we are going to discuss a so-called zero single point of failure setup with bonding, zero single point of failure setup without bonding, and we will show also a setup without zero single point of failure, just using 10 gigabit adapters. In many cases in your server there will be only two 10 gigabit ports, and we can in the session today we want to show how to utilize this kind of hardware. Also short discussion about ping nodes, how to use them. We will show this live. Heartbeat path, so-called auxiliary path, performance. Performance is of course very important stuff with the virtualization, because mostly you will have plenty virtual machines running in the virtual environment, so this is why the random IO should be good. This is why you should use the latest technology from Adaptec, which is Max Cache, or LSI, which is a Cachecade. Latest Cachecade 2 is using read and write cache. Also 10 gigabit Ethernet solution. There are options to make this as a switchless. We have the blog article about it. If somebody is interested, always please give me a call. I can also explain how it works, because the setup is not so obvious. But also there are very low cost regarding to some very expensive solution. 10 gigabit switches, Cat6 based, 8 port or 12 port from Netgear, are really inexpensive, so you can use the 10 gig technology already at a low cost. Active load balance cluster. Our DSS V7, this is a active load balance, means we have a active means both nodes are active, but always we need at least two volumes, because the first volume is active passive on node A, and the second volume is active passive on node B. Or first volume set, because I can have, let's say, 5 or 10 volumes active on node A, and another 5 or 10 volumes active on node B. It don't need to be 5 or 10. You can have one on node A and let's say 2 or 3 on node B. Okay, I will also show exactly step by step how to configure DSS V7 step by step, and how to configure HA cluster in VMware step by step, and we'll run a simple test. If that will be enough time, then we'll also destroy everything, because destroying the setup is sometimes, when you are learning how to use it, it's also very important. So next slide, next 3 slides are configuration charts. The first configuration chart is with bonding. Second configuration chart is without bonding. Both are zero single point of failure, so I have 2 switches. And the very last chart is this, what I'm going to show today, that will be without multipath. Just a simple configuration, because in the past or last let's say Hyper-V configuration, it was always with multipath. Sometimes we want to have a simpler without multipath. Okay, this I'm going to show today. Let us come back to the first slide. So multipath with bonding. So we see we have the multipath because our storage client, I have 2 storage adapters. In this case it's ETH2, ETH3. That's our first storage client. ETH2, ETH3 second storage client. Of course we can have a third and fourth and more storage clients, but it's not enough space on our chart, so I put just 2. And on the storage side, so node A, node B, our DSS, we have also so-called 2 storage adapters, but actually we see 4 ports, because we have a bonding over 2 ports and a bonding again over 2 ports. But these bonds are somehow dealing as a path. So we have the IP addresses on the first storage client 192.168.21 and 22.101, and you see 31.32.101, right? So I have 4 IP addresses here, but I have actually 2 physical paths, because on this adapter I have 2 IP addresses, and on this adapter I have 2 addresses. So that's the first physical path of the multipath, that's the second physical path of the multipath. And because on the storage side I have 4 IP addresses, because I have a 2 resource pool, so target 0 and target 1, but every target is exported via 2 IP addresses. So let us see, target 0 is exported via 192.168.2100, and the target 0 one more time is exported via 3100. So that's the target IP address, right? So 2100, 3100, that's the first target, so target 0. And you see we have 2101 and then 3101. So they're exactly accessing this target 0. And then another target has a 2200 and the 3200. It's same story. So this is with bonding, exactly step by step. You can find on our website. You can find also all the webinars with such a setup. Here, next slide, we have exactly the same, logically the same configuration, but instead of bonds we just use the single ports. So this will not change a lot here, and this is mostly already used with 10 gig, and with bonding you will mostly use with 4 gig, so you have a much more bandwidth here than with single 1 gig, right? So this is kind of workaround that we can use 4 ports for this kind of configuration. Okay, so here is almost the same, the IP addresses are stay the same and so on, but instead of bonding I have a single ports. And ping nodes, you see, look on the ping nodes. Ping nodes are here configured in the subnet 1 and subnet 2. And look, our storage adapters are also in subnet 1 and subnet 2. So we are pinging to the storage clients, and we are pinging not, let's say, over management port, but we are pinging via these storage adapters, because the ping node is used by cluster manager to check whether the storage adapters are reachable by storage client. If this is the case that the storage adapters are not reachable, so it means I have something active on node A, but the storage adapter is not reachable from node A, but the storage adapters from node B is reaching the storage client, so I should make failover. This can happen only when something is on the on this path. The problem can be that this adapter is dead, or somebody removed the cable, or cable is dead, or port in switch is not working anymore. But this is very seldom, but we have these ping nodes still. In regular case, of course, we can have the total crash of the system or power off of the system. Means the ping node will be not so important. Important are heartbeat path, and our cluster will not start with single heartbeat path. We need always at least 2, and by default we always put the heartbeat path on the volume replication. In this case it is ETH3, and on this volume replication we also have always so-called heartbeat path, so auxiliary path. And another heartbeat path supposed to cover also the storage adapter. So in this case, I can have the heartbeat path on ETH3 on 2 and 1, but there will be also not error if you make it another one on 0. Coming back to our bonds, look, the heartbeat paths here will be also on ETH5 in this case for this one, which is for volume replication. Then ETH3, 4, it's a bond 1, and the ETH1 and 2 it's a bond 0. And look, bond 1 and bond 0 is also in subnet 1 and 2, so 1 220, 2 220. And look, our ping nodes, they are not shown on the storage client. They supposed to be shown on the storage client. Somehow we show a ping nodes in somewhere in the network, but they are also 2 and 1. The best practice is putting these ping nodes just or configuring these ping nodes on the storage client and not like here using any other device. But if this is not possible, okay, no choice, we can use also this way. Okay, and the very last chart, this is what I'm just going to show how to configure this kind of configuration. We have shown here. I don't have 2 switches because I will not have multipath. You see, I have 2 adapters here on the storage client, and the storage client is exactly VMware ESXi cluster. And you see this ETH1 I have point-to-point because this will be vMotion. For vMotion, you can also connect between both servers not using a switch. If you have 2 servers, of course. If you have a more, that will be a problem. So you must have a switch. But for 2 servers, you can just connect each other. Of course, if you have more adapters, you can also connect without switch, more nodes than 2. But okay, in our case we have two nodes, so we have a point-to-point. If I will use switch, will be the problem? No. But then I save some 10 gigabit ports because I have also 10 gigabit adapter here. And the ping node, same story. You see my storage adapter is 192.168.1.220, or on the right side 1.221, so subnet 1 I can say. So you see my ping node is also 101 here, and this 102 here. So look, my storage clients, the very last segment of the IP address is always ending with 101, and this is good practice. And here is always ending with 102. Okay, and the volume replication also direct connection. Here we have ETH3 is the link for the volume replication. This is also 10 gig. So I have a 2 10 gig port in my storage servers, and I have 2 10 gig adapters in my storage client. There is one more adapter for management. I didn't put this because it is actually not so important when we are learning now the cluster setup. Okay, so let me switch to our demo servers. So I was rebooting both, so I should be able to log in now. I was deleting the content of units, so the clusters, our storage cluster needs to be formatted new from scratch. So when I go volume groups, I will see the unit available. You see it is available, not formatted yet. So I just selecting here and applying. It will just make the volume group on top on this. Okay, same story on A. So I have a already names DSS-A, DSS-B, and very important stuff is that you rename the host node. Okay, the host name. I will show you this when I start the formatting because it takes few seconds. So okay. So on both nodes, I just create a volume group. On the second node, the volume group is created already. So we'll be creating our logical volumes. In order to make it simple, I will create only 2 volumes, so minimum what I need. And I will click on the volume group 00 and I will start to create my logical volumes. Let's say I can create 500, 501. This is also kind of good practice that your iSCSI volumes are not identical in size. So here iSCSI volume, use volume replication. When I use it, then I will not need to wait for initializing, because this will be recognizing that both are identical. So my iSCSI volume 500 gig, the first one, and the same story on node A. I'm creating also iSCSI volume with volume replication and also 500. Okay, the first pair is created. So let us create a second. That will be also iSCSI volume, and I will take 501 here, and same I will create iSCSI volume and 501. Okay, so my volumes are created. So now I need to set the volume replication direction. By the way, when you click on help and index, you will see active, passive, and active quick starts. So please download and print this and go step by step, because this is a very important, very short written, just one A4 page. That's it. It's not only setup but also description how to test it. Okay, so this is very important. I didn't show that, on my NAS, on my network settings here, network interfaces, I have already a host name, something like this, host node A. This is not very good practice. In the help we say that you should have node A and some random number, because you cannot have two hosts with the same name in the network, because something like node A, it can be very popular, and then it is a big probability that you will have two of them. So this what I have here is not really very good practice. Only when you are sure that you will have only one cluster in your network, you can use this. Otherwise, just put some random number. Okay, then I need to set the volume replication direction, because my two volumes are created. So you see both will be showing on the both server. They will be showing as a source. So I have created two volumes here, and I have created on the A same. So I need to make the source on the first volume set on the A, and the source on another volume set. In our case, I have just two volumes, so the volume 00 will be source here, so this one will be destination, and opposite on the B, this one will be destination, and this one will be source. So we have a two volume pair which are mirrored. 0 is mirrored A to B, and 1 is mirrored B to A. So when I'm on A, then I can already create the task. But before to create the task, we need to bind both nodes, put them together. And here is very important. You need to put them together on the network path which is responsible for volume replication. So don't make mistake here and don't put, let's say, 192.168.0.221. I will come back to our so you see 0.220, 0.221. This one I'm using for the web GUI access, and 1 it is used for iSCSI target, and the 3 is used for volume replication. So here I will use 3, right? So don't make mistake here, please, admin, because you think you have volume replication on 10 giga, you put 0, and there will be volume replication on 1 gig, and you will be surprised that the performance is very low, and then your customer will create ticket. So we are binding and we are also setting with this operation the volume replication link. Okay, and now we can create the so-called volume replication task. So mirror 0. You can also put the name you like, but I'm just like short, so volume 0. M00 for the first task. You see there is no speed limit because now everything works in the dynamic way. So the speed is dynamically recognized. So the task is created, so we can start this task. And on the B, we create also the task from the B. We create and start the task. The reverse was of course automatically created, so when I create M001 and I'm starting, the reverse is automatically also created on A. So we have always M00 means that's the task which is so called at home here on B, and M001 is called reverse, so I know this task is at home on B, not on A. Okay, M0 is at home on A, and M001 is at home on B. I can see because of this name. Okay, the tasks are created, so now we are exporting iSCSI targets. So I need to create the targets, and the targets must be identical on both nodes. So let me remove the DSS because the target consists of the IQN date of creating the target and the server name dot and alias. So alias is target 0, so I will just create this way. So the first target is created. To save time, I will also go to the second one while this is creating and also do the same. So now I'm removing this and removing this B. So you see that's okay. And then I have 2 volumes, so I need 2 tasks. Sorry, 2 targets. Target 1 in this case, and target 1 also here. Okay, targets are created, so now I go to A and I will apply logical units to targets. So I will join them, so attach. So I need a SCSI ID, copy this, because when I'm attaching this, I will be attaching with the same SCSI ID on the second side. You see, this SCSI ID gets some random number from the volume ID, so this is why on both nodes will be different. But I need this to be exported with identical name. Oh, sorry, I clicked on help. Okay, so now I need to override, so I paste it. Okay, so now we have a logical unit 0 on both, and the SCSI ID is the same, and the target name is the same. So same with the first one. With the second target, so target 1, because I'm starting from target 0. Okay, so I copy this, attach, and I paste this here. I need to select target 1. Don't attach them into the same target. So now I'm selecting the target 1, and then I'm pasting this. Okay, so now every target has a own logical unit. You can have 2 or more, or even 8 logical unit, or even more than 8, but please do not attach more than 8 volumes into one target because of the performance reason. Okay, but the best is always 1-to-1. Okay, targets are created, so now the last step, we need to create our failover configuration. The auxiliary path, so the volume replication path is already created for us. So now we select the ETH1, which is our iSCSI target path, and that's minimum, and that's enough. We don't really need to create another heartbeat path. If you add with this ETH, let's say 0, that will be not a mistake, but we don't really need it. And now ping nodes, we need to ping our storage adapters. So I will create ping nodes 192.168.1 and 101. That's my first node. Probably this one is not created yet, so I will have unreachable, or maybe this was not really deleted yet, so it is staying reachable. I will check, because I wanted to make kind of step by step. So it is reachable. Okay, let me see. 192.168 again 1 and 102, the second node. I was expecting unreachable on the first node because I thought I was deleting the network setting. Let me see on the login failed on 101. Let me see. (102) I can log in. I will try one more time. Aha, there is maybe something to confirm. Yeah, so let us log into this host. Because connection failure, unable to connect to remote server. Okay. I will try one more time. Okay, 101 root. Okay, I have my colleague on the session as well. I would like to ask him to check what's going on with this host, why it is not reachable right now. Okay, Adrian, can you confirm that you will take a look on this? I hope you can hear me now. Okay, so my colleagues will check what's going on with this host. Why? Probably maybe there is some connection problem with the cables or switch, or I don't know, because I didn't touch it and it was reachable all the time. Okay, so I will continue until I will get it fixed. Okay, so we have this both reachable. As I mentioned, I will try to make it unreachable. I will try to delete this on this, at least on the one host. So next step is add virtual IPs, and the virtual IPs we will add on ETH1, because ETH1 is our iSCSI target export. So the IP which I was predicting here is, you see, 192.168.2100 for my target 0, and for another target that will be 3100. That's what I'm going to do. Okay, it's good to have some documentation that you know what's going on. There is no chaos. So 192.168.2100 is my target, and 255.255.255 it's a mask. Good. So now it is adding my first virtual IP. So my iSCSI target will be accessible from the storage clients via these virtual IPs. We have two targets and the two resource pools. So okay, in this resource pool, for this we add target 0, and this one will be by default or by start active on node A. Okay, we have here node A resources, and in case of failure, it will be activity will be moved to node B. But later on, we can always balance and move activity to node A with this move button. Okay, so the so-called first resource pool is already created. And now look, I have this virtual IP, I have this single target. If you have an active passive solution, then you configure only one resource pool. So means all the volumes you have are active whether on A or B. You cannot have them, part of them active here or here, because all this resource pool is showing on which node they are active, all these volumes. If I have two resource pool, then I have a load balance, because the volumes which are in the first resource pool can be active whether on A or on B, and the volumes which are on the resource on the second resource pool are also active whether on A or on B. I have question, does the virtual IP for the resource pool move over to node upon failover? Yeah, virtual IP, right. Virtual IP is whether active on A on B. In this case, now it is active on A, so this virtual IP is sticking to node A. When I will move, so I can move only when the cluster is started. I'm just configuring that, so cluster is not started. So as long as a cluster is not started, this IP doesn't work. So when I start the cluster, the IP start to answer. Okay, let me configure the second, so that in the second, first I configure the volume, so the target volume is exported via target, so I'm just touching the target, and here I will add the second virtual IP. This is why my two volumes, one 500 gig and second 501 gig, which are defined in my storage cluster, they will be exported via these two iSCSI targets, and both are mirrored each other, and the first will be active in the starting position on node A, and the second pair will be active in the starting position on node B. This is why I'm balancing the load, because imagine you are reading from the first volume, and you are reading from the second volume. So physically you will be reading the first from node A, and you will be reading the second from node B. So you are using power of two servers, 192.168 and 31. Okay, if I will have both volume active only on one node, when I will be reading of course from one node, and the second node will be just doing nothing. In this case, in active you have a better hardware utilization, of course. Okay, both resource pools are defined already, so we can start the cluster. Oh, you see, I have already unreachable, so probably I can, by meantime, I can try to log in. Oh, it's better already. And I can try to log. Oh, and by meantime, I will be starting the trying to start the cluster. The problem is that when everything is unreachable, you cannot start the cluster, right? So when you will properly define only storage adapters and your cluster is not configured, so you will need some maybe fake ping nodes or some other ping nodes by meantime, which you can maybe remove later on. But you can also, in the same time, you can go to your storage cluster nodes and go to networking and see what happened here. So look, I have a switch 0. Okay, switch 0, switch 1. I don't know what is it. Okay. Okay, very good. So we have these two nodes. I will show you what is configured here. We have configured the Oh, did I remove the management or what? I see that it is a problem here because my management network is not showing. I have two adapters, and let me scroll it. So it looks like here there was really a problem because I have wrong configuration on the 01. Oh, I don't know if I will be in the position to fix it during the webinar. Okay, remove, because this is supposed to be management network. Looks like somebody really killed my configuration by meantime. Oh, that's very bad. Let me pause the recording for a while. Okay, so we can continue now, and then here I had to make some reparations. So we have a management on 192.168.0.101, and we have a redundant adapters here. This is important for HA cluster. Same story will be on the 02. You see, I have here I have a redundant adapter on my management network, right? And here I have already defined the switches. I didn't delete the switches, so I have a ping node, then two iSCSI path, so the iSCSI 31 and 21, right? And always 102 on the end for this 10 giga adapter, and I have a vMotion adapter, right? It's also 10 giga adapter. So I will do the same on my 101. So that's my management. So this one is my ping. I just defined the ping. So maybe I will check here. So both ping nodes are still available. What happened when I will go to properties and let's say add my iSCSI adapter, so VM kernel, of course. So that will be iSCSI 21, and then I will put the IP address of my initiator, so 192.168.21 and 101, because I'm on 101, so 255.255. Okay, good. And then one more to the second volume, of course, VM kernel. That will be iSCSI 31. So 192.168.31 101, because I'm on the 101. So mask regular class C. Okay, we have the both iSCSI targets, and we have a ping node, right? So what happened when I will just edit this and let's say remove this ping node? Okay, I remove this ping node. So what happened here in the few seconds? Of course, this will change to red if everything is working properly. Okay, so it is changed to red, and now if I want to fix the problem, so I will be able to go again and define my ping node. So I go to properties and just add, of course that will be kernel, VM kernel. I will put the name ping, let's say 1, okay, subnet 1, 192.168. This is in subnet 1, and I'm on 101, so 101 mask Okay, great. So our switch is already done, and if I check here, then it's changing to green. Okay, so my cluster is ready to start. I will start my cluster, and starting cluster takes maybe 1 minute, so by meantime we can finish configuration here. Maybe you have seen that on the 102 next to my switch with iSCSI and with the ping node, I have one more for vMotion. So that's the VM kernel port. And look, I put here 192.168.50.102. That is also on my chart here. That's the vMotion connection, 50, 101, 50, 102, right? So I have a 50, 102. So on my very first node, I need one more networking VM kernel, and that's the 10 giga adapter, the last one. And I will put okay vMotion. So I will have a, of course I need to select this. If I forget, then of course I will have errors later on. Okay, I will have a dedicated link for vMotion. So 192.168.50. You can use any free address. So 101. Oh, wrong. Good. So that's, we are done. So when we done, I have just login also to my vCenter, and in vCenter I will need to create my data center. So demo. In the data center we create a cluster. So cluster will be HA. We turn on vSphere HA. That's enough for us, and all the default is for us great. So in HA cluster we will need to add our nodes. So I'm adding the first node 192.168.0.101 and login. Okay, so we have a first node, and let us okay, first node and the second node. I'm login. Okay. Great. So both nodes are there. The network configuration is already done on both nodes, so we can see the configuration is done. So we need to connect our storage. So I go to storage adapters, and on my iSCSI adapter go to properties, and I will need static discovery. You can have dynamic, but it is strongly recommended to add static. It's a bit more because you need to enter the target name 192.168. Our target IP is 2100, and the target name we can get from our DSS. So when I select the first target, and here I can try to copy. Okay, I Control C. So I paste it. So it's target 0. I copy one more time. Okay, target 0, and second one, so it's 192.168.3100, and now it's target 1. So I'm connecting to both targets. And then binding, so I will have a 21 and 31. They are already there. So if let's say I can remove them and show how to edit. So add, so I select 21 and add, then I select 31, right? So also you see the ping vMotion is already nice description, so you know which one is which one. Close, and then rescan. So if we're lucky, then we should see here both logical units listed. They are listed, so we are connected. Same story on the second node. So when I go to configuration and the storage adapter, so click on right mouse, okay, properties, I add the targets, so 192.168.2100, target 0, okay, and one more target, 192.168.3100, and the target 1. Okay, so I'm connected to both. Maybe also binding, we check, it's already okay. It's a remind from my previous configuration. I was running a test before the webinar, so this is why I didn't delete everything. Okay, so now it is in progress. You see the bar is in progress. Now it's completed, so both nodes are logical units are there. We don't have multipath, so we don't need to go and let's say define the managed path, because we have one path, so there is no multipath here. And then I go to the first one, I go to storage in the configuration, and I will add my data store. So disk, this is a disk, this is not NFS, this is iSCSI, so I'm selecting the disk, and then I will see all the available logical units, and then I will format them. Loading takes few seconds, so we need to be patient. So while we are configuring, on the beginning we have some here errors, but this is not a big deal. So this is good. You see here I have 501 and here I have a 500. Later on, if you don't have different size, you don't know which one is which one, because you need to go to this this unit number, and this doesn't look nice. So if you want to know exactly which volume is which one, the good practice is to have a very small size difference. And you know, I know the first one is 500, maybe I will do it in the sequence. Okay, you see I see this keep existing signature and so on, because my disk was not really totally destroyed. So I will format the disk. This you will always see when in case of kind of crashes and so on, and the data is still there, so the VMware recognize the data. I will format the disk. Okay, all partitions will be used, and then disk will be formatted. I put the name iSCSI, let's say first volume. And now it is, you see, always you need to have a look at the bottom. It's in progress, so it's formatting the first data store. Okay, completed. So we have the first one, and we need to add the second one. So okay, the second one, I also format the disk because this was not really destroyed. iSCSI. Okay, by meantime, let us see if there are any questions. Okay, if you have a question, just type into the TeamViewer. Okay, so both volumes now in seconds should be added, and when we add to the cluster node, so the second node must have them already. It takes some time, a few seconds more, or maybe just refresh. Then both nodes must appear here properly. If not, then you have a error. But yes, it is now it is true. You see both are there. So now it's a time to maybe make some virtual machine. So I have on my local store here, I was preparing a machine. So this is the thin, so I have a 40 giga, but it's only 7-8 giga size real. So I will just add this machine to my inventory. Okay, I will just put TMP. This is a temp machine. I want to just clone. Okay, so look, we have put the temporary machine. I need just to access my image and clone it. So I will create, let's say, demo VM, and on my HA cluster, and first node is okay. This error message or warning you have because it's a CD-ROM device configured. If you don't want this, you can unconfigure CD and it's okay. So now I will cloning to my iSCSI store, first one. I don't need to change, so now it is already in the progress, and it is cloning my virtual machine image from my local data store to my cluster data store. I selected this way because within 1 minute I have already virtual machine which is ready to run and to make some tests. This is just Windows 2012 R2 virtual machine. So while we are copying, it will take few seconds more. I will check the cluster, the storage cluster. You see I have a status local node is active here, the first resource pool, and the second resource pool is active on remote node. Yeah. So node A, first resource pool is active local node, and the second resource pool is active on remote node, right? When I go to another one, I see this opposite, always the node is listing the own resource pool first. So I'm on B, so look, the node B show the own resource pools as local here, and then the resource pool from node A is active now on remote node because we are on B, right? Good. We can also make some very simple test, and we can move resources active from A to B. So when I click on move, it will be moving the activity from A to B. And so that's the failover from the first resource pool. And after this is done, you can move it back. So now it is active on remote. So everything is active now on B. So you see the first resource pool is active on remote node, and second is active on remote. This is after, let's say, rebooting of the node A. But you want to balance, so means we want to move back home, right? So this will be moving activity back. Okay, so what is persistent reservation sync? I have a question. Okay, so this persistent reservation sync is an extra cluster layer which is required by Hyper-V cluster or by Microsoft cluster. So Microsoft cluster technology is using persistent reservation, and we need to sync between both storage nodes because we are mirroring servers. So we call it persistent reservation synchronization. You don't need this for VMware Oxen, or you don't need this for the regular Windows nodes. You need this only in the cluster, but we have this active always. So that will be probably a good idea to have this as enable or disable. We are thinking about preparing such a version that you can start it optional. It's not really a big problem because there's only some reservations commands replaced between the cluster, so it's very low traffic, and we have it by default. Okay, so coming back to our vCenter, so here everything looks already almost great. So this TMP I can remove from my inventory already. I don't need this machine. So I have one machine. I see some alarms here, so I can go and see what's going on. There is an alarm with some host power status. I can acknowledge and I can clear this message if I don't want to see it anymore, if I know what's up. So my cluster is already configured. I'm starting my virtual machine and I will need to check whether everything is working well. So for sure the machine is started and machine is protected. If it will be not the case, you will need to go to the cluster nodes and run this reconfigure for vSphere HA. If you will see any warnings or any messages, then you will need to reconfigure, and you see this is just in progress. For very first time when you will install, you will have this problem. I was doing this in the past, so it was already not showing as a problem. But when you will install very first time after installing virtual machines, you will need to reconfigure, or after reinstalling the very first virtual machine, you will need to run this reconfigure. So please remember, on both nodes you will run a reconfigure for vSphere HA. Takes a few seconds, and once this is done, then you will see no warnings here. Like here we see, and when I see here summary, there is a warning on initial, okay, election, so it is in progress. You will see under summary the warnings here, some errors or some tips from the software which you need to change. Also, when you will have only one single adapter in the networking, here for the, you see, for your management port, when you will have one single NIC, also you will have the error or warning just, okay. So now when I'm selecting my VM, you see that the VM is already for HA protected. My VM is now on the first node because I see 101 here, and my VM is residing on the SCSI 1, so on the first pool. So I can go and migrate. I can change the host. I can change the data store, right? So changing the host will be moving from 01 to 02. Okay, so I will need to select this one. So it was 101, and after moving will be 102. And you see the progress is at the bottom. Okay, so now it's done. So I'm on 102, but the machine is stored on the first pool. So we can also move to another pool. So when we change data store, and then we select second one, confirm it. So now it is showing that it is moving the machine from the SCSI 1 to SCSI 2, so from the first 500 giga volume to the second 501 giga volume. And during these operations, you can always make a problem to your storage. Let's say the first one can be switched off or can be just rebooted. I'm restarting. So on the B, you will see that on the B, the B resource pool is local, and the A1 was on remote, but now it's also on local. It changed by meantime because the first node is just rebooting, right? So you see the persistent reservation is already inactive, and sync will be also inactive in a few seconds. Okay, it's not synced because I'm alone now, so this node is running alone. The first one is not available anymore. Of course, I'm getting some errors messages and so on, and my storage systems are just working. I have here, you see my storage on both nodes is all the time available without any problem, and the migrating is migrating between both storage pools. So we will need to wait some time until this is moved, and by meantime we can also think about starting to removing everything. When the migrating will be done, I can start to removing everything, and I can check if there are any questions. Okay, so far I don't see any new questions. If you have any, just type. Let us check the machine. Okay, that's my machine, and I can try to log in, so I can go to okay. Okay, so by meantime this machine is already relocated, so you see here is on SCSI 2. That was probably a bit longer because I was having an error with the first node was shut down at this moment. You can move between storage and nodes even during the failure with the one of the node of the storage. You see, when the first node of the storage will be already starting coming back, so first we will see the replication state, so that's the service which is starting one of the first. And then when the node A is fully booted, then as the last is this persistent reservation starting, so will be active as well. Everything, the activity will staying on B, so we'll need to click the move button to load balance, so to move the originally first resource pool running also on A. So it takes, of course, some time to reboot the machine. If the machine will reboot without any problem, then we will see soon this replication state. I can make some checking running command, so I will just ping this 0 to 120. That was the one I was rebooting, so it is still unreachable. So it's not really very important for me right now that it will be starting, but if we still have time, we can have a look. I was planning this webinar for 1 hour, so we are already 1 hour 10 minutes. So I will probably conclude this. So what we have seen today, we have seen step by step with Open-E DSS V7 active load balance cluster, and we have seen how to connect these to a VMware HA cluster. So VMware HA cluster is a cluster which is not as redundant or as available, I will say, as DSS V7, because DSS V7 is having this kind of fault protection. Here we have a fault tolerance, call it. That's the higher level of HA, because without fault tolerance, when the node A which is running the machine will be out of service, the node B will be restarting the machine. So we'll have a short stop of service, and the fault tolerant will be transparent. Same like DSS V7, the failover is transparent, right? So we have seen this live demo. Everything worked well, and yeah, that's great. I don't see any more questions. Then I would like to say thank you very much for joining the session. I would like also to invite you for the next one. We will be sending new webinar invitations soon. We will be showing the new products very soon. So one more time, thank you very much for joining us, and have a nice day, and see you soon.